Alright, hello guys. I hope you guys had a great spring break where you got to relax a little bit and not have to continually check in with your schoolwork stuff. But as of now, we're going to go ahead and get right back to it. And we're going to go ahead and finish up our nervous system. So I've got some cool stuff kind of planned for us here in the next couple weeks. So today we're going to look at the layers that protect your central nervous system, so how your body has naturally created almost like layers of armor to protect that very important brain and spinal cord that we've been talking about. Tomorrow we're going to get into some brain injuries and brain disorders, so we'll talk about traumatic brain injuries, concussions, we'll talk about strokes. We'll also get into Alzheimer's towards the end of the week and discuss like what research has been done, what do we know about it, what are the causes of it, and possible treatments for it. After that, there's going to be a Google form survey because I'd like to show you guys a video, and I'm working out the logistics of that. So towards the end of the week, you'll see a Google form survey pop up. Please do take that because that's going to help me figure out what platforms I can use to show this video to you as well. Okay, and make sure everybody can see it. But for today, let's go ahead and get right back into our central nervous system. So remember, your central nervous system is consisted of your brain and your spinal cord. And with that central nervous system, we know compared to the rest of the organ systems, it is not nearly as strong or even as durable sometimes when it comes to like the physical aspect and the ability to get injured. So with that, your body has actually made a bunch of natural adaptations and layers to protect these two very flimsy parts of the body with the brain and the spinal cord. So our first layer of protection, okay, is obviously the layer that you can see right now. It's your skin, which consists of like that hard keratin, that connective tissue underneath your skin, so some of the adipose tissue and other things. And then your scalp, which is kind of the common term of all the connective tissue plus the muscles, is what your scalp usually consists of. Okay. If you continue to work your way further in, you have your skull. If we're talking about the brain, obviously there are lots of layers built into the bone, like your periosteum, your endosteum, and then with your spinal cord, we're going to be looking at the vertebral column, where you literally have bones wrapping around your spinal cord to protect it. The third thing that we've got for our central nervous system is meninges, and that word is almost as good as the word phalanges. Alright, so the meninges are going to be membranous layers, so they're membrane-like layers that help to keep the brain in place, keep it together, and also perform that protection. And then the last thing is this watery cushion that we've been talking about before spring break, which was the cerebral spinal fluid. If you remember, your ependymal cells are the cells that actually create this cerebral spinal fluid, and that will actually help to cushion it in its place. So if you kind of look at this diagram here, we've got your skin with some hair on it. The muscles would be kind of involved with that too. They're not really shown in this diagram. And then we would get into like the bone and the different layers of bone. Then we'll get into some of these meninges, or the meningeal layer here. And then if we keep working our way down, we look past some of this other stuff, we've got this like blue layer. That's to symbolize the watery cushion, which is that cerebral spinal fluid. And then your brain right here. Okay, so lots of layers go into protecting that very important organ. Alright, so with our meninges, okay, there's several layers of meninges. The first meningeal layer is called the dura mater. Sometimes you might have heard this like on TV shows maybe, but the dura mater is going to be a double-layered external covering. Okay, and even though it's not spelled like matter, like what we've talked about in other science classes, that's typically the most common way of saying dura mater. I don't usually hear dura mater. Okay, so it's double layered. It's an external covering, and it is found. So we have our skin, we have our bone, and remember the outermost layer of our bone is the periosteum. And then underneath all of the bone tissue, we've got the dura mater, which is in this blue coloration in the diagram here. Okay. The dura mater, okay, is going to be underneath the periosteum, okay, and it is the outermost covering of the brain. I don't really like how I organize this. This periosteum should kind of be off by itself, not underneath the dura mater very well. Alright, but with your periosteum, remember periosteum is the outermost part of the bone. Okay, the meningeal layer is going to be that covering of the brain, and then the dura mater is the outermost covering of the brain. Okay, so periosteum bone, dura mater is the actual like meninges. Now your dura mater isn't going to be perfectly round. It's going to fold in several parts, and it's going to go ahead and fold in where we find the major like fissures or crevices of the brain. So there'll be, for example, a fold where the corpus callosum is, where that like the two hemispheres come together. There'll be a fold there. There'll be a fold where the parietal and the temporal lobes meet. Okay, so some of those major folds will be where this dura mater kind of follows the line or follows the curve. Okay, right underneath the dura mater, we have the arachnoid layer. And if you're like, arachnoid sounds familiar, we did talk about it in biology, and you've probably heard it in other places too, like arachnids, like spiders and ticks, okay, and mites, okay, are all arachnids, as are scorpions. Ugh. Okay, so you actually have a layer of your brain named after those arachnoids. One of the reasons why they are named after that is because they have this web-like appearance. Now on the next slide, I'm going to give you your warning now. On the next slide, I have a picture of a cadaver head, and it's like from the top view, so you can't see the face of it, but you can see the cranium part, and it's got all of these layers separated out. Okay, it was actually a picture that popped up on my Instagram a couple days ago. I was like, oh, that's perfect for what I'm about to need it for. Oh, timing. Alright, so what you're going to see that web-like layer. It looks kind of like spider webs, which is why it's named this. This is the middle meningeal layer. So, dura mater is the outside meninge, arachnoid is the middle meninge, and the last one is the pia mater. Okay, so the pia mater is the internal layer, okay, that you can kind of see right here. It is going to cling to the surface of the, yay, picture, brain is what that word is right there. Okay, so clings to the inner surface of that brain. Okay, here's that picture I told you about. Alright, so what we're looking at the top of the head, so from a superior view, and the anterior or the front is right here, posterior back right here. You can see the ears are kind of sticking out. So this is actually the different layers that we've got that help to protect our brain itself. So here's our scalp, all right, which has like the skin, the hair, and the muscles and connective tissue, okay? So this one is actually kind of broken down even more, okay? So here's our scalp, which is mainly skin and connective tissue. If you remember the word aponeurosis, okay, that is the tendon-like material that connects our skin to our muscles. So you can actually see they've actually cut even down to the muscular layer. Okay, so this is probably the very front part of the parietal muscle. Yep, right there. Okay, and then cutting even deeper still, so we're working from a more superficial to a more deep area. We've got some more connective tissue, because remember connective tissue is kind of everywhere, and then we have the periosteum. This is the outermost layer of bone. Okay, and then if we cut further into, like past this periosteum, we've got this middle layer, and that's like the true bone tissue itself. So there's the person's skull. Okay, so we have a lot of layers before you even get to the skull, and then you have some more layers after that. Okay, now you're going to see here as we get into like the deeper layers, we're going to start having like cross sections, so you can see the cranium really easily here down the middle. You can also see a thin layer of it around there, and that's just the cross section of where they made the cut. Okay, so cranium. Okay, after that we're going to get into our dura mater. Our dura mater is our first meningeal layer, which is a very membranous thing. At first it kind of looks like the epicranial aponeurosis, but it is much deeper. Okay, it's also a lot thinner as well. So the dura mater is this kind of white, kind of blotchy looking layer here. Okay, it is the outermost meninge. You can see where it kind of like dips in a little bit here and here and here. And then if we could see it, there would be a major dip in right here. Okay, and that is your dura mater. If we cut that dura mater away, okay, you can see a little layer over there. We're going to get to that arachnoid layer. Now the arachnoid layer, a lot of times people think like it should be white because they think of like spider silk as being like that clear white color. But it's actually usually like a pink or magenta-ish color, just because of it's so close to the brain. Now, if we were to hold this layer up away from the pink brain tissue itself, then we would get a much clearer look to it. But it's so thin and web-like that it tends to take on whatever color it's laying on top of. Okay, so that's why it looks kind of pink here. But when they look at it under, either if they like hold it up to the light, or if they look at it under a microscope, it looks very much like a spider web would. Okay, and that's your arachnoid layer right there. Now the pia mater is very, very thin, to the point of a lot of times you will actually need a microscope to be able to see this layer in some parts of the brain. It's also typically a clear layer, so the ability to actually see it very well, it's kind of hard. Alright, so there is a really faint clear covering over top of this brain called the pia mater, but you can't really see it in most pictures. You can, however, see the brain or underneath that pia mater, which is what those folds are right there. Okay, alright, we love cadavers. Okay, so with your, okay, we've worked our way through. The thing that you don't see in that last picture is the cerebral spinal fluid. And a lot of times when we do cadaver work, cerebral spinal fluid, you can't see it, okay, because it's either drained out, or it's mixed with preservatives, or it's absorbed into the organ itself. So cerebral spinal fluid is more one that you would see during like a live surgery, or if you're looking at brain scans. So cerebral spinal fluid, it's similar to like blood plasma in composition. So blood, think about like when you like skin your knee and that like clearish stuff kind of comes out, okay? That is sometimes the plasma like of your blood mixed with lymphatic tissue, okay? So similar in what we find in other fluids of the human body. It is formed by the choroid plexus, okay, which is part of the diencephalon of your brain, and it's filled with those ependymal cells which make that fluid, and it forms that watery cushion to help protect the brain. It's almost like a water balloon that helps absorb a lot of the shock. It is circulated in the arachnoid layer, which we just looked at, the ventricles, which if you remember from before spring break are the holes in the brain, or I shouldn't use the word holes, the chambers of the brain, because remember we have 4 chambers. Okay. And we find it in the central canal of the spinal cord. Okay, so we find it running through the spinal cord too. So everything you see in blue here is representative of your cerebral spinal fluid. Okay. And once again, helps to be like the shock absorber. So like if you were to like hit your head against something, that fluid is important because it helps to reduce the shock and reduce the injury to that organ. And I'll go ahead and show you these and then we'll be good for today. So you can see we've got cerebral spinal fluid throughout the ventricles, here where the ventricles are in your brain, those chambers. Okay. And then you can see it's all around the outside too, and even down through the spinal cord. Okay, and there's actually like a flow to it, okay, almost like a river would flow. The cerebral spinal fluid also flows based on like the movement of your head, okay, and if you move your head really quick, because those cells are continuing to produce more cerebral spinal fluid. Alright, if you guys have any questions whatsoever, please let me know. My time's coming to an end, so I hope you guys are doing well. I will talk to you more about brain injuries tomorrow.